Now coming to the properties of hydrogen, that is the chemical properties of hydrogen. Now hydrogen, what you find is that when it dissociates, alright, a huge amount of energy is being given out, huge amount of energy. It is estimated that when H single bond, it dissociates at a temperature of around, alright, this is nothing but H single bond H, we can write in this way also, H2. So the temperature is 500 Kelvin and 95.5% dissociates. Alright, to give you what? H plus H, you will be getting it. So it is 433 kilojoules of energy. What you can say is that is nothing but liberated. You can write this H plus S as 2H also, you can write it down. You can write it as 2H also, you can write. So what you find is that a huge amount of energy is being that is liberated. That is 433, around 433. What's more than 433? It is actually 433.85 kilojoules of energy. What you can say is that is being liberated. Clear? So huge amount of energy. Alright, a huge amount of energy is required to, what you can say, break this particular bond of the bond between hydrogen and hydrogen, so to say, the bond between hydrogen and hydrogen. So it has, for that reason, that is, it has got a very high bond dissociation energy, very high, because hydrogen bond is a very strong bond. Why it is very strong bond? Because hydrogen atom is very small, so the bond length is very small, so bond energy has to be very large. For that particular purpose, it requires a huge amount of energy to break this particular bond, and this energy is liberated when again this hydrogen combines to form a hydrogen molecule. We can say that this much amount of energy is being liberated. So what we find is that that here, that is it dissociates into its atom in only, what you can say, very small percent. We can say that it dissociates it in its atom at temperature is very less, around 200 Kelvin. If you take the temperature, then it dissociates to a very small extent. But as you go on increasing the temperature, the dissociation increases. The rate of dissociation increases. The yield of hydrogen, what you can find is that it increases. Clear? So at around, what you can say is that that is 500 Kelvin, or we can say that is, sorry, at around, sorry, 5000 Kelvin. I'm very sorry, here it is 5000 Kelvin. It is around 5000 Kelvin. That is, the rate of dissociation is 95.5%. But if you take the temperature, as I said, you are on 200 Kelvin, the rate of dissociation is less than 1% also, we can say that. So as we go on increasing the temperature, the rate of dissociation increases. The yield of hydrogen also increases, so to say. So in this way, that is, for that particular purpose, hydrogen molecule is stable at a room temperature because the bond is very small. Alright, H2 molecule, H single bond H, that is H2 molecule, is quite stable at room temperature because the bond length is small. So bond length is small means huge amount of energy, as you see it here, huge amount of energy is required to break the bond. Huge amount of energy is required. This much amount of energy is required to break the bond, which is not available in the ground state. So hence, for that particular purpose, it is quite stable at room temperature, so to say. So, and also it requires, I said you, high dissociation energy to break the bond. This much amount of energy is required to break the bond also. Alright, and temperature also, you can see how much the temperature is. So next is we find that hydrogen is neutral in nature. Already we have discussed with it reacts with blue or red litmus solution, or blue or red litmus paper. It should be moist red litmus or moist blue litmus to remain as it is. Alright, so it does not change the color of moist red litmus paper or moist blue litmus paper. We can say that it remains as it is. So for that reason, it is being proved that it is highly I'm saying it is neutral in nature. That hydrogen is neutral in nature. It is neutral towards litmus. Now, if you see the combustibility, hydrogen is a combustible gas. Alright, it burns in air in presence of oxygen. So when I say air means in presence of oxygen. With a pale blue flame, it burns in air. Alright, and it is not a supporter of oxygen. Alright, it does not support oxygen. But when it burns in air, it burns with a pop sound. Pop. Alright, so in this way, hydrogen and oxygen, H2 plus O2 will give you nothing but 2H2. Alright, so in this way, what you find is that when hydrogen burns in oxygen, it burns with a pale blue flame. It is not a supporter of combustion. Alright, it burns off with a pale blue flame. And dry hydrogen, reacts vigorously with oxygen. This is dry hydrogen, I'm saying you. It reacts vigorously with oxygen. Got it? And it forms what you can say water. So for that reason, in coal mines, you see sometimes we heard it or in TV or in news that in coal mines this explosion was there, because what happens is in the coal mines, large amount of hydrogen is being trapped inside it. Large amount of hydrogen is trapped inside it. So when the miners are working under it, so what they do is that they make some way for the oxygen, or they carry also oxygen cylinder with them. Or it's maybe due to some leakage of oxygen from the cylinder, or some oxygen what you can say which comes inside for the miners to breathe. Alright, we are also making some way now for the oxygen, for the air to come inside, so that the miners can breathe, because every time they cannot work with oxygen cylinders. So what happens is that when a huge amount of hydrogen is being trapped in the coal mines, got it, for years it is being trapped, these hydrogen reacts with oxygen to form an explosive mixture. A huge explosion takes place in the mines, we can say that sometimes, got it, when the miners are working inside it. Got it? So to prevent that, we are using many safety precautions, definitely, to see that this explosion does not take place. Got it? But sometimes it happens, it's an accident, it happens. Got it? So in this way, the miners are being pulled. In that particular case, the miners are being pulled into the surface, from the mines, they are pulled into the surface, we can say that, so as to prevent any other accident or any sort of what you can say accident, to prevent it. So it is being done, we can say. But a huge amount of hydrogen is being trapped inside the mine. Generally, it is being presumed that. For that purpose, when we know that generally a huge amount of hydrogen is being trapped, so precautions are taken initially right from the beginning, so that no such explosion or no such accident occurs. We can say that. Fine. So when hydrogen reacts with oxygen, when ignited, so this dry hydrogen, it gives a spark and it produces what you can say water. The reaction is highly exothermic in nature. Huge amount of energy is liberated. Again I say, it is highly exothermic. For that reason, I told you while preparing of hydrogen, while collecting hydrogen, I have said that the few bubbles of hydrogen, because hydrogen is being collected by the downward displacement of water. So the few bubbles of hydrogen is not being collected. Why? Because that particular hydrogen reacts with the oxygen, and it can form an explosive mixture. So to prevent that explosion, we are not collecting the few bubbles of hydrogen. Alright? Clear? So we do that. So in this way, the reaction is highly exothermic. Here you can see that. So it is an oxidation reaction. This particular reaction is where hydrogen is oxidized to water. We can say that. Clear? Fine. Where hydrogen is oxidized, and generally oxygen is reduced also, we can say that, because oxygen is gaining hydrogen. Gain of hydrogen is also called as reduction. Gain of hydrogen is also called as reduction, we can say that. Clear? Now next is when it reacts with a chlorine gas, with halogens. Now hydrogen gas and chlorine gas, when it reacts in dark, if I take dark, no light is there, then the reaction is negligible. No reaction is going to take place. Alright. If I take diffuse sunlight means, what is that? Diffuse sunlight, the sunlight which is penetrating through doors, windows, which is coming into your room, that is called as a diffuse sunlight, indirectly. The sunlight which is coming through the doors, windows, which is being penetrating into your room, that is called as diffuse sunlight. So in presence of diffuse sunlight, it gives you 2HCl, that is gas. Alright, hydrogen gas plus chlorine gas, it gives 2HCl gas. So in case, in presence of diffuse sunlight, it gives you 2HCl gas, and the reaction is quite quiet. Alright, the reaction is not so, what you can say, vigorous, not so explosive, because if you do this reaction in direct sunlight, outside, we can say that, if you do this reaction in direct sunlight, then the reaction is explosive in nature. Alright, because chlorine is highly reactive. For that reason, the reaction is explosive. So what I say is that, in presence of dark, the reaction is negligible. In presence of diffuse sunlight, we are getting HCl gas. But in presence of direct sunlight, when you do it outside in the open, the reaction is highly vigorous. It can be explosive also. Now, here it depends that if I take chlorine and if I do this reaction in diffuse sunlight, the reaction is possible. But if I take fluorine, alright, you know fluorine is more reactive than chlorine. Got it? The reactivity decreases in this order. Fluorine, chlorine, bromine, iodine. Now for fluorine, if I do it, if I take H2 plus F2, got it? So here dark, the reaction is possible. In case of dark, the reaction is possible, we can say that. Clear? It gives you 2HF. Yes, in dark the reaction is possible. When hydrogen reacts with fluorine. Got it? Clear, the reaction is possible in dark, but in chlorine the reaction is not possible, we can say that, because I said you fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. Iodine is the least reactive, we can say that. So in for that particular case, iodine and bromine, we can say that. Now for fluorine it is possible in dark, for chlorine it is possible in diffuse sunlight. Now for bromine, what we find is that in direct sunlight it is possible, the reaction is not so explosive. And iodine in direct sunlight also it is not possible. If I take here iodine, if I take H2 plus I2, then I need to heat it. I need to heat it. H2 plus I2, I have to heat it. Then only it is going to form 2HN. That's it. So in this way you can know the reactivity of halogens with hydrogen. Alright. In fluorine, dark, diffuse sunlight is required for chlorine. For bromine, direct sunlight will do. And for iodine, heating is required. You can see heating is required in case of iodine. We can say that. Clear? So in this way, what we find is that the reactivity of the halogens also can be justified from this particular reaction, so to say. Now, next is what we do is that we take here, that is nitrogen. Another element we'll take, that is nitrogen. So we will see what it happens when hydrogen reacts with nitrogen. Now, next is what we find is that nitrogen is inert under ordinary conditions, because nitrogen has got 3 bonds. For that reason it is inert under ordinary conditions. Nitrogen is. So for that particular purpose, when hydrogen reacts with nitrogen, alright, so the condition is 450 to 500 degrees centigrade temperature you have to give. The pressure is 200 to 900 atm pressure you have to give. And iron is used as a catalyst and molybdenum is used as a promoter. See, under these conditions only, 3 molecules of hydrogen reacts with nitrogen to form 2 molecules of ammonia, and heat is liberated. It's a highly exothermic reaction. It's a highly exothermic reaction. So in this way, what we find is that hydrogen, when it reacts with nitrogen, under these conditions, all these conditions you see, then only the reaction is possible. Why? I said you, nitrogen is inert under ordinary conditions. See, I am not saying nitrogen is an inert gas. No, I am not saying that. Don't get confused. I am not saying nitrogen is inert gas. Nitrogen is inert under ordinary conditions. Under room temperature, nitrogen is inert. Alright. So to make it reactive, we have to give these conditions. Then only it will be reactive in nature. Why it is inert? The reason is nitrogen has got 3 bonds. N triple bond N. And to break these 3 bonds, a large amount of energy is required. And conditions are required. So for that particular purpose, nitrogen does not react with any of the element or with any of the compound under a room temperature. It reacts only at elevated temperature. Under conditions only it is going to react. And this process you will be reading in higher classes. It is called as Haber's process for the preparation of ammonia. This step which I have written it. Got it? It is nothing but the Haber's process. H-A-B-E-R apostrophe S. H-A-B-E-R apostrophe S. Haber's process for the manufacture of ammonia. We can say that. Clear? In this way, ammonia is being manufactured by this way when it reacts with hydrogen, so to say. Now, next is after that, when hydrogen, when it reacts with sulfur, that is a non-metal. Of course, this is also a non-metal. So, under conditions when hydrogen reacts with sulfur, that is the condition is that we have to that is heated, this particular one, that is when it reacts with sulfur under 700 Kelvin, then what it forms? It forms gas, which is H2S. H2S, you know, it has got a rotten egg smell. Rotten egg smelling gas, the gases. It's a very poisonous gas. This particular one is having a rotten egg smell. That is H2S. Now, next is when carbon reacts with hydrogen. When it is being heated at a temperature of around 1273 Kelvin, what it forms? It forms methane, CH4. Got it? Similarly, it can also form acetylene also. Got it? Like 2C plus H2. It forms in presence of electric arc. Electric arc means that is you will take 2 electrodes, this sort of, and you will bring it closer to each other. An arc will be produced. Arc means just a spark will be produced. That is said to be as an electric arc. In presence of electric arc, where a temperature of around 3500 Kelvin is being produced. A temperature of 3500 Kelvin. So what it will give you? Acetylene. This is known as acetylene. It is an organic compound, and this is your methane. This gas is methane, and here this gas is acetylene. So acetylene is being produced, we can say that. So in this way, what we find is that when carbon under different conditions, we can say that, reacts with hydrogen, it forms, this is also an alkene, this is an alkene which is methane, and this is nothing but known as alkyne in organic chemistry. It is alkyne, we can say that. That is acetylene, so to say. So in this way, acetylene gas is being produced when carbon reacts with hydrogen under different conditions, we can say that. This is the formation of hydrocarbon. Together we can call it as hydrocarbon. Takes place, the formation of hydrocarbon, so to say. Clear? Now, we can also say that, like suppose, let me rub the board, then I will say you. That is, when hydrocarbon reacts with hydrogen, hydrocarbon means like alkenes and alkynes. When it reacts with hydrogen, what it forms is that it forms a saturated hydrocarbon, which is called as alkene. Listen carefully. Alkene and alkyne, they are known as unsaturated hydrocarbon. They are called as unsaturated hydrocarbon. Alkene and alkynes. Alkenes has got carbon-carbon double bond. Alkynes has got carbon-carbon triple bond. When it reacts with hydrogen, it forms carbon-carbon single bond, which is alkene, and it is saturated. Alright, that particular hydrocarbon is saturated. Let me give an example to you. For example, C2H4, when it reacts with hydrogen in presence of nickel as a catalyst, or nickel, platinum, palladium, anything you can take it as a catalyst. In presence of nickel, platinum, palladium as a catalyst, you will be taking it. So what you will be getting? You will be getting C2H6. Now this is ethene. It is an alkene. It is unsaturated. It has got, see, the structure is this. This is the structure. It is carbon-carbon double bond. You are knowing it, of course. Alright, it is ethene. Now, this is your ethane, which has got carbon-carbon single bond. Of course, you know it is. This is ethane. So, from alkene, this is your ethane. We can say the name is ethane. So, from alkenes, it gets converted into alkane. From double bond, it gets converted into single bond by the addition of hydrogen in presence of nickel as a catalyst and heated. We can say that. Clear? So in this way, what you find is that this particular one addition reaction, you may heat it or you may not also. That is up to you. Clear? So in this way, this reaction takes place, and this is called as hydrogenation of oils. Generally, vegetable oil. Vegetable oil means soybean oil, groundnut oil, we can say that. Clear? The vegetable oil. It is being converted into vegetable ghee. That is the Banaspati ghee, we can say that, by the process of this only, which is called as hydrogenation of oils, we can say that. Basically, the oil, if you keep it for a long time, this Banaspati oil, got it, like your soybean oil or this groundnut oil, got it, this palm oil, if you keep it for a long time, then what it becomes? It becomes rancid. Got it? Because it reacts with the oxygen which is present in the air and becomes rancid. Rancid means the smell comes out and the oil is no more suitable for consumption, we can say that. Now, to prevent that, what we do? We convert the vegetable oil into vegetable ghee. That is, from double bond, we convert into single bond. So, this process is called as hydrogenation of oils. It is used to convert the vegetable ghee like dalda, we are using it in your house, na? Dalda, Rath, Gagan, these are the different companies, we can say that. Clear? Where a double bond is completely broken to form single bond. That is, an unsaturated compound is being broken to form the saturated compound, we can say that. In certain cases, I will tell you, heating is required. In some cases, heating is not required. If you are heating it, let us say if you are heating it, the temperature is around 473 Kelvin, then the reaction becomes faster. If you are not heating it, the only difference is that the reaction is slower. That is, we can say that. The only difference is that. So here, that is the polyunsaturated oils is being converted into, that is, saturated oils. If you are not doing it, then what happens is that the oil, that is vegetable oil, becomes rancid. Rancid means a smell comes out and it is not suitable for what you can say consumption. So to prevent that, again I repeat, to prevent that, we are converting the vegetable oil into vegetable ghee, we can say that. And this process is called as hydrogenation of oil, we can say that. Clear? So in this way, it can be done. Similarly, if I take here acetylene, let us say, just I was saying you, acetylene, see triple bond. See here, this is double bond alkene, this is single bond alkene, this is triple bond alkyne. So when it reacts with hydrogen, alright, what I like it, same thing, nickel and heated, we can say that. You can take any catalyst. I can take nickel, or you can take platinum or palladium. What I'll be getting it? I'll be getting CH2 double bond CH2. See, it does not make any difference if I write hydrogen here or here. It does not make any difference. So again, it reacts with hydrogen in presence of Ni, alright, to form, what is that? That is CH3 single bond CH3. Just you add it, see, CH2. So one hydrogen is added here, one hydrogen is added here. See here, hydrogen is added here. Again, it reacts with hydrogen and heated. Of course, heating sign has to be there. So it is heated to form what? CH3 single bond CH3. Again, one hydrogen from here is added here, one hydrogen from here is added here, and we get this. So triple bond gets to double bond gets to single bond, so to say. In this way, the reaction is being carried out. We can say that the reactions is being carried out, that is for hydrogen. Thank you.